Hello, boys and girls. This is Dr. Barnes. We're doing now Chapter 4, Probability, and this video is about reading 4.1, Basic Concepts of Probability. Now, my only apology is probably the fact that it took us a while to get here, and I probably should have done this a little bit earlier because it really is crucial. And again, you're going to see that with all the content that's being relayed on this. Now, the textbook opens up talking about reading 4.1, and there's going to be two parts. The first part is Part 1, which is underlined right here. Part 2, as you can see, is crossed out, and that's because we're not going to cover it. It's not an issue that I think the handout should require you to read and fill in information about, and it's also not something that we're going to be doing with our problems. What do we say about Part 1? This section includes basic concepts of probability. The single most important objective of this section is to learn how to interpret probability values. How do we interpret them? Well, the one thing that we just sit back and need to know is the fact that probabilities range from 0 to 1. And that's really key, and I say that because I've talked to some individuals one-on-one, and I've had them not really understand that probabilities only range between 0 and 1. There's been some activities in the homework. If someone gives you a probability and you're talking about 1.1, that's not really a probability. It might be a ratio. It might be some other clever way of presenting information, but it's not a true probability value. Probability values range from 0 to 1. 0 meaning that event Zero meaning that event never occurs. A probability that's very small, like 0.001, you might say it never occurs, but truly it's an event that rarely occurs. You may not witness it in your lifetime, but it does occur. And then you can have an extreme value that's always likely to occur, which is a value of 1. But we know in life that we fit somewhere in between there. And right dab smack in the middle is 0.5, which is an event that's probably likely to occur 50% or half of the chances. Now, that's kind of the basics about a probability, and we're going to dive into the rest of the aspects a little bit later with some other issues and conversations. What is the role of probability in statistics? Well, of course, probability plays a central role in hypothesis testing. We make decisions by rejecting claims based on very low probabilities. You guys know and have probably seen before alpha. We will reject the null hypothesis if our p-value is less than alpha. So we'll get the p-value from our experiment. And if we had technology and we were using technology, we'd see the p-value a lot more. But calculating it by hand, it's kind of trivial and it doesn't make sense. But when you're using statistics in computer-generated outcomes or software, you can really just look at the p-value. And when you look at the p-value, you will know that you can reject the null hypothesis if the p-value is less than our alpha. So we make decisions by rejecting claims based on very low probabilities. And again, that's going to be crucial when we get a little bit further. Now, I'm going to take a little sidebar and have a couple items that we're going to talk about through this lecture. And the first thing we're going to be talking about is Kim Kardashian. And I just want to do something different from the textbook. I was going to use John and Kate plus 8, but I think that's like old news and you guys might not know what it is. So I will talk about what's hot now. I think it's Kim Kardashian. Kim Kardashian has stated in an interview that she wants to have a family of 8 children. She thinks she's going to be the new Octomom or John and Kate plus 8 or maybe Angelina Jolie of our time or your time. Actually, Angelina Jolie probably is my time. And then later on in the interview, she was adding that it would be perfect if it were 6 girls. Now, first of all, I think when people say stuff like this, like I want a boy, I want a girl, I almost want to slap them because I think the most important thing is that the child's happy or healthy. But, people say things like that. And you can sit back and dispute whether she'll get what she wants. But we're not going to sit back there and talk from our ignorant opinion of what might happen. We're going to use statistics and to see if we could see how likely it is that she could get her perfect wish of her children. Now, looking at this table right here, this is a binomial distribution. The reason why it's binomial distribution because we're talking about the probability of a girl out of 8 children. Now, you have to realize there's 2 possible outcomes. When you have a child, it could either be a boy or it could be a girl. You're talking about sex, a boy or a girl. That's it, right? Now, we're talking about she wants children of 8 children, so we're having a units, about 8 units discussed right here. This is the probability of the number of girls that's likely to occur if you have 8 children. And you can sit back and see the probability of these things occurring from this distribution, which is illustrated right here. Now, she said she wanted 6 girls. Looking on this chart, you can see the probability of getting 6 girls is 0.109. That is 10.9% chance of happening. I'm not saying it's impossible, but it's a 10.9% chance of that occurring. I'm sorry if you can't read that, but I think you're following what I'm saying. Now, each of these values right here is showing you the probability that getting each of these outcomes. The possibility of having 8 children and 0 of them being girls is 0.004. The possibility of having 8 children and 2 of them be girls is 0.109. The probability of having 8 children and 3 of them be girls is 0.219. Now, after you get to the very top of the probability of having 4 children, you'll notice that this distribution starts looking symmetrical. And even better than that, it even starts looking familiar. This looks very similar to a normal distribution. And this is one of the reasons why statisticians oftentimes use a normal distribution to approximate a binomial distribution, even when you're using 8 units, which isn't even a lot. This distribution starts to look like a normal distribution. Trust me, if you're doing considering instances, you might very well consider instances in which you're thinking more of 8 units. Well, right here it's 8 children. Anything more than 8 children, I'm thinking is a little absurd. But no offense to anyone with large families. But again, very quickly, a binomial distribution starts to begin looking like a normal distribution. And as you can see, the probabilities of each of these things occurring. Now, food for thought. Let's go and sit back. Now, I mentioned before, Kim Kardashian might be on television talking about what she wants to do. Let's entertain some of this that she has. What is the probability of having 6 girls? Now, looking at this, we have to go here. This right here is where 6 is. The probability of that written is 0.109. That translates, when we move this over, to a 10.9% chance of having 6 girls. The probability of having 6 girls, looking at this, is 10.9%, or a probability of 0.109. What percent chance does she have to have 6 girls? Same exact thing. We kind of answered that already. Much apologies. And is the chance probability significantly low or high? Now, I think a 10% chance of talking about having 6 children, that's pretty low. I would not bank our any amount of money on that, right? But it's not as low as individuals. So even though you might sit back and think the probability of her having 6 girls is low, right? It isn't to the level of being significantly low. Because I mentioned before, saying something is significantly low would have to be less than alpha if we're using our age-old trusty psychology alpha. That's 0.05. 0.05 is not able to sit back and say that we could reject this. So a psychology would not sit back and say it's a significantly low probability of having it. It's low, 10.9%. I wouldn't bank any money on it, but it's not significantly low because our 0.109 is not less than our 0.05. I'm just going to write that right here. 0.09 is greater than our 0.05. So we wouldn't say that it's significantly low if we use our psychology standards of alpha. Now, also, what do we consider significantly low? I'm going way out of order, I apologize. But what do we consider significantly low would actually be anything less than 0.05. Now, there are some instances that are less than 0.05. Probability of having 0 girls is 0.0004. The probability of having one girl is 0.031. The probability of having 7 girls is 0.031, and the probability of having 8 girls is 0.0004 again. So that's what we would consider the probability of having what would be really significantly low or high. But again, the 6 children, even though it's unlikely, it's not something that we would consider significantly low. So anyone that watches this interview and is thinking like, oh, you're dumb, that would never happen. Yeah, if we're a psychologist, we really wouldn't say that. It is a low chance, 10%, but 10% chance is something that might be worth banking on depending on who you are. It could happen. Now, what are some basics of probabilities? Going back to this, in probability, we deal with procedures such as generating male and female births or answering multiple choice test questions that produce outcomes. This is something that we deal with a lot, generating male-female births or answering multiple choice questions. It's kind of what I did right now, but I added it to a little twist with Kim Kardashian, answering multiple choice questions, and these things all can produce probabilities. Now, in order to sit back and understand these probabilities, one of the things we're going to do is talk about the relevant definitions. One, we want to understand what an event is. An event is any collection of results or outcomes of a procedure. Now, I think what's probably even more important to understand what an outcome is, but it's talking about a procedure. What is a procedure? In our previous example, we were talking about having 8 children, right? So 8 children is the procedure, because we're not really going to roll the dice, but we're going to actively try to attempt to have 8 children, right? So an event is a collection of results or outcomes of a procedure. So all the ways that you could have, let's say, 2 children, all the ways you could have 3 or 4, that's what a procedure is. Procedure is always defined by, the number of units that we'll have. So in our example, 8 children equals our procedure. Any event in a collection of results that define that procedure. Now, what is a simple event? A simple event is also relevant for us to sit back and know and understand. A simple event is an outcome or an event that cannot be further broken down into simpler components. Now, when you're sitting back there and you're thinking about, I mentioned before the ways that you can actually have 2 girls. When you think about birth order, you could have 6 boys and then 2 girls at the very end. You could have 2 girls at the very beginning and then 8 boys, or the girls could be spread out somewhere in between. A simple event is an outcome or an event that cannot be further broken down into simpler components. So the fact that we say the probability of having 2 girls, that can happen a number of ways. So it's not a simple event. And that's because you can break down that event into something that has many ways of occurring. A simple event is broken down into its simplest format. Now, I know this language might be a little bit confusing, and we'll show how these things can kind of relate to each other in the next slide. The next you want to understand about probability is the sample space. The sample space for a procedure consists of all possible simple events. That is, the sample space consists of all outcomes that cannot be broken down any further. Right? So we got event, simple event, sample space, and we talk about procedure. I'm going to try to use this example right here to try to sit back and reiterate all of them. And hopefully by looking at them and talking through them, it can help you understand some of these concepts. And I'll come back to this slide if I remember. All right, so what is a simple event? Simple event is an outcome that cannot be further broken down. The sample space, however, consists of all possible simple events. That is, the sample space consists of all simple events. Now, let's sit back and think about possibilities. Now, I don't want to go as far up to 8 births with Kim Kardashian, but I will sit back and entertain some examples that will help you understand how they differ across other situations. Let's sit back and say that we're focusing now on having 1 boy. So that's the simple event that we're talking about, an outcome that can't be broken down any further. Now, our procedure is one birth. So, we're only going to have one child, and we're worried about having a boy. Now, what is an example of what would be a satisfactory situation? It would be having a boy. This bracket is talking about the arrangements you have. You had a boy, right? Now, the sample space of what could happen in a single birth, you could have a boy or you could have a girl. That's the sample space. Because if our procedure is having a single birth, there's only two ways that could happen. When you have a child, it could be a boy or it could be a girl. That equals 2. That is our sample space. Now, let's amp it up a little bit, because a lot of people like to have large families or multiple children. And let's say our procedure now is having 2 births, right? And the event that we're interested about is having a simple event, right? That is having one boy. Now, it's kind of implied with this that if you have one boy, then you're also going to have one girl, and that's because we're talking about a procedure of 2 births. Now, how many ways can this happen? You could be a mother, you could have a boy, then you could have a girl. You could be a mother, and you could have a girl, then you could have a boy. There's no other way that this could happen. If you have 2 boys, you don't have the simple event of having one boy. You have 2 boys. That's something else. So, there's only two ways that this can happen to satisfy that event. Now, when you sit back and think about this procedure, however, procedure of having 2 births, then you think about the sample space, all possible simple events. Not the simple events that we're just interested in looking at, but all possible simple events. We can have 2 boys, we can have a boy and a girl, we can have a girl and a boy, or we could have 2 girls. So our sample space with 2 births is 4. But the event that we are talking about right here is having a simple event of one boy, and there are only 2 ways of that occurring. So 2 out of those 4 possible ways allow us to have one boy. Anything else is unsatisfactory. We would not be satisfied if we got this outcome, because we got 2 boys. We would not be satisfied if we got this outcome, because we got 2 girls and no boys. But we would be happy if we did this and we did that, because we, at the end, would have had one boy. And that's what this person wants in their perfect family. Let's do the same exact thing now for 3 births. Our procedure is 3 births. Now, the simple event that we're looking for, right, the event that we're looking for is one boy, and we only want 2 girls, of course. That's my ideal family. Now, how can this happen? There are a couple of ways for this to happen. We could have a boy and then 2 girls. We could have a girl, a boy, and a girl. We could have 2 girls and a boy. So there's 3 ways that this could happen. And I'll tell you, my parents had some friends who were trying to play these kind of games in terms of wanting a particular sex. But there's only 3 ways that you could have 3 children and have one boy. Now, the sample space, however, of 3 births is much longer than this focus of we want one boy out of our 3. The sample space is all possible outcomes, and there are 8 possible things that could define the possible ways of having 3 births. I'm not going to go through all of them, but they're listed right here. You can pause and do that if it helps you. And again, out of those 8, what I will do is highlight the instances that are matching what we would consider to be a success. Those 3 that are underlined would be a success out of our sample space. 3 situations or instances in which we have one boy, and then ultimately the flip side of that is 2 girls. Now, again, there's a lot of information in this chart, and I want to go through it to make sure we understand. Let's talk about 4 births. Now, the event that we're looking for, we got this family. We want one boy and 3 girls, almost as weird as Kim Kardashian, right? Now, how would this occur? Couple of ways. Some examples of events out of a procedure of 4 births. We could have 3 girls right in a row and a boy. 2 girls, a boy, a girl. Still got 1 boy. A girl, boy, girl, girl. Still got 1 boy. A boy, and then 3 girls in a row. Still got 1 boy. These are all examples of events that would satisfy what we're doing. But now we got 4 births. Our sample space has increased quite a bit. There are now, 16 possible ways that a family could have 4 births. I'm definitely not going into all of those, but you can, and the handouts are printed on D2L if you want to go through them. Now, this right here, oh, this is real sad. But I mentioned I want to talk about what Kim Kardashian. This is a picture of Kim Kardashian. I don't know. I guess they're in a home. Looks like it's security detail back here, or that, or paparazzi. I have no idea what's going on over here. But yeah, right now they have 3 children. She's well on her way. And actually, I didn't know this until doing this, but she's having I guess it's called surrogate children, in which people are I guess her eggs and I guess the sperm of Kanye West are being inserted into a caregiver. So they're able to have children without, I guess, her messing up her having time off of working, and then also not messing up her body or figure, which, trust me, I'm sure for her is extremely, extremely important. So right now they have 3 children. I say a disclaimer because this is as of, I looked into this research, which was the 18th of 2019. Don't talk to me about how she has 4 children, etc. No. This right here was true when I wrote it. All right, now, there are 3 common approaches to finding the probability of events, and we're going to talk about all of them today. And I got a couple activities that I think will allow us to kind of understand them, at least I hope, in ways that are not expressed in a textbook. Now, we have the relative frequency approximation of probability. The relative frequency approximation. Now, to do this, we look at the number of times event A occurs. Now, event A can be whatever it is that we're talking about, right? And then the number of times the procedure repeated. Now, if you think this goes back to how many times did a boy occur, right? And then the number of times the procedure was repeated, right? So we're going to sit back and have 4 children. That's the procedure, repeated 4 times. The number of times an event occurs of having a boy, right? That's how we can sit back and find a relative frequency approximation, right? Now, that's not as good as what we're going to talk about a little bit later, but it is a way of doing it. And if you're not mindful, people can make decisions from this. It's not that you made it a mistake. It's just you used a relative frequency approximation when you probably should have used one of the other ones. But let's look at the example that I have to sit back and illustrate the relative frequency approximation, right? I had this conversation with a student. It actually happened just recently, right? I'm not going to say who it is, but I will share the essence of the story of our conversation so you guys can follow along what's going on, right? A colleague had reached out to me, and they were looking for advice about getting disrespected by students when they were having class. Now, I offered them advice, and they came back to me and were saying, like, it worked, thank you. I was just like, wow. But in my mind, I was unsure because I don't feel like I really get disrespected by students, right? So I'm saying this in front of the student, and they're just like, yes, you do. Remember that one time? And I was just like, wow. And actually, the yes, you do, remember that one time, the remember that one time came back a little bit late. So I'm just like, wow, like I'm getting disrespected by students? Maybe I just don't remember it, right? Now, I don't remember the situation, but of course, it's kind of beside the point. But let's use this example to calculate some relative frequency approximations of probability, right? Now, what we're going to do is this. Let's go to sit back and say this is me. Teacher, I be me, right? Now, we're sitting back. This faculty member comes in like I do, Tuesday, Thursday. We have 2 days a week, 15-week semester. Now, the semester's not over, so when this person reached out to me, let's say we've had 28 classes, right? Now, I could sit back there and say with my recollection, right, I'll give this person the benefit of the doubt. I feel like I might have been disrespected one time or annoyed into the classroom by students directly, but I'll inflate it a little bit and do 2. Let's do 2. So 2 out of 28 times. Now, that's the number of times event A occurred. Now, right here, event A is disrespect in classroom. I'm not talking about in a group chat when y'all upset in your rooms. I'm talking about disrespect in the classroom, right? So 2 out of 28 weeks, right? Now, to sit back and to calculate that probability, we were just going to simply divide 2 by 28. When we do that, we're going to get a value of 0.071. Now, what we're going to do is we're going to round this up. So when we round this up, 2 probability points is probably the best thing to do. So we always look at this point right here. Since this 1 right here is less than 5, we're just going to leave this by itself. So we would round this to a 0.07 probability. Now let's talk about the teacher who needs help. Teacher who needs help, they have 28 classes as well. How many class periods were they disrespected in class? Let's say that they are 12, right? That's just my number of time events. This person was saying it happens a lot, frequently, etc., etc. Now, let's do the math for that. 12 divided by 28 equals 0.428 probability. Now, again, with probability, let's round it off to 2 points. How do we do that? We look at this right here. Now, since this 8 is greater than 5, we're going to round up. Since this 8 is greater than 5, we're going to round this number up. So to make this 2 decimal points, it would be 0.43 probability. That's looking at the relative frequency approximation of probability. That's how we would do it. We're looking at the number of times event A occurred and the number of times the procedure was repeated. So we had class, this is the procedure, 28 times. Ample opportunities for anybody to disrespect a faculty member every time you meet with them in class. How many times did the event occur? I'm giving myself 2. It might be higher. Who knows? Maybe I just have like a blind memory. Versus the 12 of the individual who's seeking my help and saying it happens all the time, et cetera, in their classroom. That's how we calculate the relative frequency approximation of probability. For this situation, it's a good opportunity. It's a good way to address and to calculate this probability. Now, there's other forms of probability as well. We can do the classical approach to probability. Number of ways A occurs, and then the number of different sample events. Now, to talk about this, I'm going to sit back there and talk about a pretty funny interaction that I guess I had with an individual. They were sitting back there. It's funny because it never happens like nicely, right? But I got a conversation. My grade on the 3C, which you guys are all familiar with, I failed. There is no way that I could have failed that assignment. Well, there is a way that you could have failed that assignment. So let's sit back and think about this and think about how we can make this 3C assignment relevant to identifying and determining the classical approach to probability. Now, to understand about the 3C assignment, right? 3C assignment, there's a couple things that you wanted to do. The first thing you have to do is kind of do a summary of the chapter. Then I sit back and talk about some 3 skills sets that you could use in the course, and then talk about 3 suggestions on how to improve the course. Holy crap. Y'all see that? Check this out. I might be calling my assignment the wrong thing. Maybe I should be calling this thing the 3 S's from now on. I don't know, that just sounds kind of weird. I like 3 C's. 3 C's sounds a little bit more professional, but summary, skills, suggestion. Right? Now, let's imagine that the way that we grade this exam or the 3C assignment is as simple as it's a 3-point assignment. You get 1 point for the summary, 1 point for the skills, and 1 point for the suggestion. Now, it's not that simple, but let's just imagine with me. So let's sit back and look at this. 1, 2, 3, 4, 5, 6, 7. All right, I think this will work if I do it this way. All right, so we got a line right here for the summary, skills, and then the suggestions. Now, You guys know I grade with a rubric. I think it makes me, sometimes I question whether it makes me a not fair or too rigorous instructor. But I get the rubric and I go through to make sure that you satisfy all these aspects of the assignment. Now, there's a couple possibilities that an individual could get. You could sit back and get a grade that looks like this. You could not do the summary, not do the skills, not do the suggestion. As you know, you're going to fail that. You could not do the summary, give me the skills, give me the suggestion. Now, that would probably be a 66% if it's out of 3 and 2 are done, but 66% isn't really failing. You could get a 0 on the skills summary, 0 on the skills, and you could also do the suggestions. You could also get a 0 on the summary, a 1 on the skill set, and then also not do the suggestions. You could also do the summary, do the skills, do the suggestions. That's a person who's going to pass, of course. You could do the summary, not do the skills, and do the suggestions. 66%, but it's not failing. You could do the summary, you could do the skills, and not do the suggestion. So again, that's still not failing. Or you could sit back and do the summary, not do the skills, and not do the suggestions. So this right here, a person would get a 0% grade. This person would get a 66% grade. This person would get a 33% grade. 33%. This is 100%. We like this student. It's a 66%, 66%, and then also a 33%. Now, the student told me there's no way that they could fail the assignment. Well, actually there is a way. And using the classical approach to probability with this right here allows us to see just what probability or what chance there is of that occurring. Now, what is the number of ways A could occur? Because A is failing. Let's go and count. How many ways can you fail? This right here, I think that's failing. No doubt about that. This right here, I think that's failing. 33% right here, I think that's failing. And we might get into some wiggle room, be like, Dr. Burns, I don't like a 66. I ain't accepting that. But it's not failing. So that's not, but this right here is. So let's go back to this equation. What is the number of ways that A can occur? 1, 2, 3, 4. There are 4 ways that this could occur. Now, the number of different simple events. Simple events that could occur, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 ways for that to occur. So using the classical approach to probability, it is 0.50. Now, this person is speaking not statistically. This person is not speaking about, truth of the matter or the fact. This person is speaking from their opinion. There's no way they could fail the assignment. But as you can see right here, there is a way. And there's actually a 50% chance if we break it down to with the classical approach to probability. And that's why the best thing to do is to sit back and dot your I's, cross your T's, use the rubric, and make sure that you are reading the instructions to ensure that you get a passing grade. Because it's equally likely if you just hand in something that you could either pass or fail, according to the classical approach to probability. Now, what is the last of the 3 approaches defining probability of events? One is the subjective probabilities event. The probability of event A is estimated by using your current knowledge of circumstances. Estimated. Now, this isn't really statistical. This isn't something anyone's really going to stand behind. But let me tell you, people do it all the time, especially in conversation. We'll sit back and be like, oh, yeah, the likelihood of Kim Kardashian having no children or 6 girls, that's unlikely. That'll never happen. We just showed you earlier there's a 10% chance. And if you're a psychologist saying that, yeah, you wouldn't be able to reject that possibility of her having 6 children by what we do. So again, Subjective probabilities are estimated by your current knowledge. And it's probably a good thing. You've never met anyone that has 8 children. And of those people that you've never met that have 8 children, you probably are estimating that it's going to be unlikely that they would have 6 children that are all girls. So it's a subjective probability. It's estimating. Sometimes in the real world, we do things like that. And sometimes in this textbook, it'll be asking you to make subjective probabilities. That's what this is talking about. Now, you want to be able to support your rationale, and it might be ignorant, it might be wrong, but that is what a subjective probability is. It is estimated by using, this is the flaw, I believe, your current knowledge of circumstances. And it's really funny because I know on my kids' softball team, I don't want to put their name out there or anything, but there is a family. They actually have 2 cars, and both of their cars were like old rentals from Enterprise. They have 15-passenger van, and that's because of how many children they have. I'm not going to put them on blast and say their amount, but they have a lot of children. Now, I don't know how many children they have or what their sexes are, but I think it's more than 8, and I think there's a lot of boys because I've seen a whole lot of them in softball. But yeah, using that subjective probability, it's estimated based off your current knowledge. It might be limited, and it could be wrong, but that's what we're asking for with a subjective probability. Just estimate based off your current knowledge. It might be wrong, but you have to do something. The only thing you can't do is pause, and I say, stand still. Think and provide us with an answer. Now, this video is about 36 minutes. I think we're at the end of how much I'm asking you to think. I'm going to stop it right now. I hope this helps you for Unit Reading 4.1, and I will see you guys after the break.